Hello, PreCalc. Here we are with 8.1, Matrices and Systems. In this section, we'll study streamlined technique for solving systems of linear equations. It involves using a matrix. Okay, and before you think this is Algebra 3 again, we are going to take a brief look at how you would set up a matrix in the old way there, and then we're going to use it basically in a whole new way. Okay, we got 5 pages of notes. They go pretty fast. All right. So you know about matrices from Algebra 2. They're labeled in rows by columns. So M by N, if it's a 3 by 4, you have 3 rows and 1, 2, 3, 4 columns. Okay, a matrix having M rows and N columns is said to be of order Mn. If they are equal, then it's considered a square matrix. Okay, take a look here. What do we have? This is just a 1 by 1. This one row, 4 columns. It's a 1 by 4. It's an empty matrix, but it's still there. 2 rows, 2 columns. It's a square matrix. That's a 2 by 2. And our last one we're looking at real quick. 1, 2, 3 rows, 1, 2 columns. It's a 3 by 2. A matrix that has only 1 row is called the row matrix, and a matrix that has only 1 column is called the column matrix. A matrix derived from a system of linear equations, each written in standard form with the constant term on the right, is the augmented matrix. Okay, that's probably a little bit new to us. Previously, we've only used the coefficient matrix, just the x, y's, and z's. So if this is our system, previously in Algebra 2, you would have used just the coefficient matrix, 1x minus 4y, 3z's. Negative 1, 3, negative 1, 2, 0, negative 4. Okay, maybe you had a separate one for the answer one over here, but for the most part, it was just basically the coefficient matrix. Okay, what does the augmented matrix look like? Okay, we still have our 1, negative 4, 3. Sometimes you'll see dots here, and then the answer. And my personal preference is to just go like a line down the middle like that. Or not down the middle, but separating the coefficient from the answers. That's how I usually do it. 1 down, 4 to go. We can use our row operations from last chapter. We can use those same row operations on matrices. We can interchange 2 rows. We can multiply by a non-zero constant. And we can add a multiple of 1 row to another. Okay, in the interest of saving time, we'll just talk about it, and then I'll put up the notes that we did in class for the answer part. Interchange the first and second rows. All right, so we're just going to flip-flop row 1 and row 2. Okay, we're going to move all those up to the top row, move all these down to the second row. And that's what we should have. Multiply the first row of the original matrix by 1/2. We're going to go 1/2 times R1, and we're going to replace it in the first row. Okay, pretty common practice because we're going to find out later how important it is to have a leading 1 in this top left corner. So we're going to multiply all those by 1/2, and we'll have 1, negative 2, 3, -1, and then the other two rows stay the same. Add -2 times the first row, and then add it to the third row. So we're going to move it, we're going to write it down here so I know what's happening to this line. We're going to go -2 times R1, and we're going to add it to row 3. So we're going to take -2 times all those and add it to these, and then it's going to replace this spot. So -2 times 1 is -2, plus 2 would be 0. -2 times 2, we got -4, plus 1 is -3. -2 times -4 is +8, plus 5 is 13. -2 times 3 is -6, plus a -2, we got -8. And those two rows stay the same. Note that the elementary row operation is written beside the row that is being changed. Row echelon and row echelon, reduced row echelon form. The term echelon refers to the stair-step pattern formed by the non-zero elements of a matrix. To be in row echelon form, a matrix must have the following properties. Any rows that have all zeros, those get moved to the bottom. For each row that does not contain all zeros, the first non-entry is a 1, or called your leading one. For successive non-zero rows, the leading one in the higher row is further left than the leading one in the lower row. Very similar to how we did it with equations in the last chapter. A matrix is in reduced row echelon form if every column that has a leading 1 has zeros in every position above and below. And below, okay? So, first one, we have a leading 1, and then we have 0, and then another leading 1, it moved in one spot. We do have a row of all zeros, and it is on the bottom. Okay, notice how we're stepping in here with our leading 1s. And let's see, I think that qualifies us for row echelon form. REF, row echelon form. Is it reduced row echelon form? That is, for every column that has a 1, does it also have zeros all the way below and above? Yep and yep. So this is also reduced row echelon form. Second one is going to be a no. We got a row of zeros in the middle. Those would have to get moved to the bottom. Here's a good example of just row echelon form. See the stair-step pattern here. We got a 1, 0, 1, 0, 0, 1. Okay, 0, 0, 0, 1, or in this case we have all zeros on the bottom. But note that it's not reduced row echelon form because we also don't have zeros above the 1s either, just below. So that's just row echelon form. And our last one, we have a 3, a leading 3. Those need to be leading 1s. So that is why that one is not row echelon form. It's worth noting that row echelon form of a matrix is not unique. Two different sequences of elementary row operations may yield different row echelon forms. However, the reduced row echelon form is unique. Okay, Gaussian elimination with back substitution. So we're going to take our system and we're going to turn it into matrices because it's slightly less writing. Slightly less writing than doing this with equations. Okay, we'll take it all the way down to the end, flip it back to an equation. and solve with our back substitution. Okay, so we have no x's, 1 y, 1 z, negative 2 w's. So we got 0, 1, 1, negative 2. I like to do the bar method here. If you want to do dots, you're more than welcome. 1x, 2y, negative 1z, no w's. 2, 4, 1, negative 3, negative 2. 1, negative 4, negative 7, negative 1, negative 19. All right, so we want to get row echelon form, and then we'll go back and back substitute up the ladder. Okay, so step 1 is I want to have a 1 for my leading spot. So I think the easiest way to do that is just flip-flop those 2 rows. And we start writing all over. So now we have this one on the top. 1, 2, negative 1, 0. And then this one slides down to the second row. And our last 2 rows don't really change. Their turn is coming soon, however. Okay, so we have a leading 1. And then we also, this worked out really well because then now it's 0, 1. So that basically takes care of those 2. We're trying to get a 1 with all zeros below it. And then we're trying to move in, make sure this is a 1, get all zeros below it. And then move in, get this one as a 1, and get all zeros below it. And then get this one as a 1. So we want that diagonal line of 1s with zeros below them. And then we'll back substitute and climb up the line. Okay, so how can I make these be zeros? Usually you would do like one thing, one row operation per step. I think we can do 2 on this first one. We're going to go negative 2 times row 1, add it to row 3. That should cancel out that 2. And then we're just going to do negative R1 and add it to R4. Okay, so notice the top 2 won't change this time. All right, now we're starting to get some action. Let's talk through this. Negative 2 times row 1. So we're going to go negative 2 times 1 plus 2 would be 0. Negative 2 times 2 is negative 4 plus 4 is 0. That's nice. Negative 2 times negative 1 is positive 2 plus 1 is 3. Negative 2 times 0 is 0, and the negative 3. And people forget to do the answer column. Don't forget that. Negative 2 times 2, we got negative 4, plus a negative 2 makes for a negative 6. Negative R1, so we got negative 1 plus 1 is 0. Negative 2 plus negative 4, we got negative 6. Negative of a negative is a positive 1. And then a negative 7 is another negative 6. Negative 1 times 0, and then a negative 1 is just negative 1 there. Negative 1 times 2, we got negative 2, negative 19, negative 21. Okay, so we got a 1 with all zeros below it. We got another 1 with a 0 below it. We need to get rid of that one. This 6 needs to go. Let's see, how can I use row operations to cancel that out? In class, some people have suggested doing 3 times this one. Okay, that would work to cancel that out, but then I'd have 3 times 1 is 3 and add it to there, and now I would lose that 0. So as we work our way down, we're going to stop using row 1, and now we're probably going to use row 2, and then we're going to use row 3. So we're going to use row 2. So we're going to go 6 times row 2 and add it to row 4. So many of these will not change. Okay, 6 times row 2 now. Try not to let your eyes wander up to row 1. So 6 times 0 is 0, plus another 0. 6 times 1 is 6, and negative 6 is 0. 6 times 1 is 6, and negative 6, another 0. That's nice. Negative 12 and negative 1, we got negative 13 there. 6 times negative 3, we got negative 18, negative 21, negative 39. So we have 1 with all zeros, 1 with all zeros. We got a 0 underneath of it. We just need to make this one be a 1, and then we need to make that one be a 1. Now, because this one's already a 0 underneath of it, and we're just going to be dividing these two rows, I think we can do 2 steps here at once. We're going to go 1/3 times our 3, because we can multiply a row by a non-zero constant, and we're going to go negative 1/13 to flip this positive to R4. Let's see what that brings about. One, 2, negative 1, 0. 0, 1, 1, negative 2. Okay, and here's our last ones now. After we go times 1/3, we'll have 1, negative 2 in those spots. And then times negative 1/13, 0, 0, 0, 1, and then positive 3. So let's change this back to equations. What does this look like? X plus 2y minus z, no w's, equals 2. We got y plus z minus 2w equals negative 3. We got z minus w equals negative 2, and we know w equals 3. Well, we got w equals 3, and we're just going to work up the ladder here and solve for all of them. So if w equals 3, z minus w, or 3, equals negative 2. If we add 3, we get 5. No, we don't. We get 1. Negative 2 plus 3 is 1. Next, we have y plus z. Z was 1. Minus 2 times w, which was 3. That equals negative 3. W was 3. So we got 1 and negative 6. That's going to be a minus 5 there. And then we add the 5 over. Y equals 2. And then our last one, x plus 2 times y minus z, which was 1, no w's, equals 2. So 4 minus 1, x plus 3 equals 2, x equals negative 1. So we got negative 1, 2, 1, 3. And as an ordered quad, we have negative 1, 2, 1, 3. Whew, there's a lot of writing. That was a lot. Take a look at that. Good work, team. Okay, let's see what we got with this. Gaussian elimination with back substitution. We're going to write the augmented matrix. We're going to use elementary row operations to get it to row echelon form. Write the system of linear equations corresponding to the matrix in row echelon form and use back substitution. So that's kind of what we just did there. Gaussian elimination with back substitution. Next, we're going to use Gauss-Jordan elimination. And we're just going to climb right back up while we're still in matrices. Gauss-Jordan elimination just climbs right back up. We're not going to switch it back over to equations. We're just going to keep on going and get it into reduced row echelon form. All ones and zeros on that left-hand side. That's basically going to tell you what everything is. Okay, so let's use Gauss-Jordan to solve. So we got 1, negative 2, 3, 9 on the answer side, negative 1, 3, 0, negative 4. I almost like the matrices better because you have the zeros, so you don't lose your open spots or get distracted. Okay, so we have a leading 1. That's nice. Next step, we want zeros below it. So this is negative 1, so it's a pretty easy one here. R1 plus R2. Now let's cancel out this one at the same time. It's a little risky doing 2 steps at once, but I like to just get rid of all of them here right away. So we're going to go negative 2 times row 1 and add it to row 3. It's a pretty easy one. I think we can handle it. So we got 1, negative 2, 3. That one doesn't change. Okay, now we're adding those two. So 1 and negative 1 is 0. Negative 2 and 3 is 1. That's a nice one. It gives us another 1 spot. 3 plus 0 is 3. 9 and negative 4 is 5. Okay, negative 2 times 1 is negative 2, plus 2 is 0. Nice. 1 with all zeros below it. Negative 2 times negative 2 is positive 4, and negative 5 is negative 1. That's a nice easy one for the next step. Negative 2 times 3 is negative 6. And 5 is negative 1. Negative 2 times 9, we got negative 18, and 17 is also a negative 1. So I have a 1 with all zeros. Bingo. And I also have the next spot is a leading 1. The next spot in is a leading 1. So now I need to get this spot to be a 0. And it's a 1 and a negative 1, so it's really easy. R2 plus R3. And I'm out of room over there, so I'll zoom out a little bit and slide back over here to the left. So we got 1, negative 2, 3. And then a 9. Okay, 0, 1, 3 with a 5. 0. 1 and negative 1, 0. 3 and negative 1 is going to be a 2. 5 and a negative 1 is a 4. Okay, so I have another 1 with zeros below it. Now this is a 2. I want that to be a 1. So we're just going to go 1/2 R3. And your hand is going to get a workout writing all these numbers down over and over and over. Okay, we're taking it times 1/2, so that's 1 and 2. Ta-da! So now you're like, okay, let's switch it back over to equations. I got z equals 2, and let's just work it back up. Okay, what we're going to actually do is we got 1s with zeros below them. If you work it back up now and get all zeros above it, it's actually going to solve it for you in matrix form without having to switch back over to XYZ. So I have 1s with all zeros below, 1 with all zeros below, 1. And we're actually going to go reverse order now when we go back up. So now I want all zeros above this 1. So it's basically like when we start going down, but now we're here going up. And again, you're supposed to only do one step at a time. I'm going to double up here just to get us going. It's a 1 with a 3, also a 1 with a 3. So we're going to go negative 3R3 plus R2, negative 3R3 plus R1. So now the bottom one stays the same. Okay, and we're taking negative 3 times this one, 0, 0. Okay, so those are going to stay. Negative 3 times 1 is negative 3. Add it to 3, that's gone. Negative 3 times 2 is negative 6. Add it to 5, negative 1. Look at that. No x's, a y, no z's. It equals negative 1. It solved it. So now we have 2 of them. Okay, keep on going. We got negative 3 times 0, 3. So 0, 1. 0, negative 2. Okay, negative 3 and then 3 is 0. Negative 2, or negative 3 times 2, we got negative 6. And 9 makes for a 3 up here. And now we're going to use this one to cancel out this. We got a 1 with a negative 2. So we're going to go 2 times R2 and add it to row 1. I'll just go right below it here. So 2 times 0 plus 1 is 0. There's 1. 2 times 1 is 2. And a negative 2 is 0. 2 times 0 is 0 plus 0 is 0. 2 times negative 1 is negative 2. Add it to 3. We get a 1. Okay, that's a real tricky spot there. It's so easy, but it's really easy to make a mistake because people get so in a rush that they canceled out this last spot and they have the 1, 0, 0, and they just jump right to doing that, and they forget to do the answer part of it. Okay, and then we have 0, 1, 0, 0, 0, 1, and there it is. X is 1, Y is negative 1, Z is 2. Ta-da! Okay. Last one. Let's see what's so special about this. (115) negative 3, negative 1, negative 2, negative 8, 5, 1. Okay. Well, I know I want the leading one, which I have, and I also want zeros below, which is going to be a pretty easy one to do because I'm just going to add that to that one and that to that one. So we'll do 2 at once here. R1 plus R2, R1 plus R3. So the top one stays, 1, 1, 5, negative 3. Okay, now we're adding these two together. 0, negative 1, negative 3, 2. Okay, we're adding top at the bottom. 0, 1, 3, negative 2. Okay, I have 1 with all zeros below it. Okay, next. Well, you kind of see where we're going here, right? Negative 1, 1, negative 3, 3, 2, negative 2. They're all opposites. So, I mean, technically what we should probably do is make this a positive 1, positive 3, negative 2, because we want these leading ones. And then you're going to try to get the zeros below it. But we can kind of see where this is going. We're going to add R2 and R3. And look at that, 0, 0, 0, 0. We've got a 0 row. So now we're down to only 2 rows with 3 letters. So it's not possible to get an actual solution from this. Okay, because you have 3 letters and 2 equations now, so it's not possible to get an actual just like answer. But we could have many answers, infinitely many solutions. So we're just going to say, hey, z equals a. Remember doing this? Z equals a. And I'm going to cheat a little bit. I'm going to flip this to 1y plus z plus 3z equals negative 2. Now I'm going to flip it. X, y, 5z, negative 3. So I'm going to flip this to positive, positive, negative. So now we have y plus 3 times z, which is a, equals negative 2. Y equals negative 3a minus 2. And then all up here to a, or for x plus y plus 5 times z, which was a. So we've got minus 3a plus 5a. That's going to be plus 2a minus 2 equals negative 3. X is going to equal, well, if I subtract the 2 over, we got negative 2a. Add the 1 over, it's going to make for a negative 1. Negative 2a minus 1, negative 3a minus 2, and then a. Infinitely many solutions of the form negative 2a minus 1, negative 3a minus 2, and a. All right, folks, there you go. That should finish up section 1, and we should be A-OK for some homework. All right. Got the rest of class here to work. Best of luck. Thanks for watching. We'll see you next time.